Hi everyone. In this video, we're going to learn how to transform a graph. So by the end of it, you should be able to apply all the various function transformations when you're given a graph and not an equation. So for all these questions, we're going to use this graph here. It's kind of an arbitrary graph. I don't know what the equation would be, so we're just going to call it f of x. That's why it says y equals f of x there. Okay. Now there are a couple different problems, and I'm going to do each problem on the same graph with a different color, starting with the red one. The first thing I always recommend is that you interpret what you see here. So it says g of x is obtained from taking 2 times f of x plus 2. Okay, so what does each of those things mean? Keep in mind that we started with f of x, so each of these numbers here transforms f of x in a different way. So I'm going to start with this x plus 2. Okay, anytime you have a horizontal transformation, so horizontal meaning it's done to the x, it's going to do the opposite of what you think. So though it's plus 2, you're actually going to subtract 2 from all the x's, which if you think about what that means, it's going to go to the left because I'm making my x's smaller. So this is going to go left 2 units, or you can think about it as like subtract 2 from each x. Okay. Whereas this 2 over here is multiplying by f of x. Right? So this is 2 times the quantity of f of x. Okay, so what this is doing, remember f of x is kind of like y, and we've even defined that up here, f of x equals y, if you scroll back up to the top. Okay, so really what you're doing is you're taking 2 and multiplying it by all the y values. So if you take 2 and multiply by the y values, a y value that was at 2 before, multiplied by 2 will now be at 4. If there was a y at 4, it would now be at 8. So what's going to happen is this graph is going to stretch out and get taller. So I'm going to write it's a vertical stretch by a factor of 2. So whatever you do to the y, it does what you think it does. Whereas the x's, any x transformation, is going to do the opposite of what you think. So it's going to vertical stretch by 2, which what you're really doing is doing 2 times all the y values. Now, in order to do this to the graph, I always say take it one point at a time. So I'm going to apply these transformations to each point. And for the first one, I might even make a table. So I'm going to start with original point, and I'm going to transform it to the new point. So we'll do original and then transformed. Okay, so this is how I approach any problem that has a graph and some points. So I will transform the original point -4, 0, for example. That's this one right here. Now I'm going to subtract 2 from the x, so the x will become -6, and I'm going to multiply the y by 2. Now y is 0, and 0 times anything is still 0. And I'm going to do this for each point on the graph here. So now -3, -2. I'm going to subtract 2 from the x, so it'll be -5. And I'm going to multiply the y by 2. So this would now be -4. And then I'll do it for the next point is -1, -2. It's right here. So I will subtract 2 from the x. So I'd get more negative at -3. Multiply the y by 2. I get -4 again. Okay, so that's these 3 points. I'm going to pause the video and do the next 1, 2, 3, and you guys should do them on your own and check. Okay, if done correctly, you should get this list of transform points. Now all you have to do is plot them, and it should look like a graph that has been shifted left 2 units and vertically stretched by a factor of 2. So let's just make sure that happens. So first I'll plot -6, 0. Comes right here. I'm just going to go through and plot all these. You guys can do it at the same time on your own sheet. So I got -5. -4. I'll scroll down a little bit more. Right here. So on and so forth. I got -3, -4. -3, -4. What else do I have? And you can see it's kind of maintaining that same structure with that constant piece here. It's just shifted around and stretched. So -2, 0. Now I got 0, 6, and 3, 0. So 0, 6, and 3, 0. So if I connect the dots, again, I still have the decreasing constant, then it's increasing, and then it's decreasing again. So it's the same structure, but it's been stretched out, and it has also moved over to, which you can see by this point here. Okay, so you want to do each point individually, but then you want to go back and check, did it match the transformations I originally listed? Okay, now a couple different things happen here that are different from this one. We did have one above that you multiplied f of x by a number, so remember that's going to multiply the y, but this negative is going to do something slightly different. So really it's saying you're multiplying f of x by a negative, which is really like saying you're making all the y's negative. And if you make y's negative, let's say you had a y that was at 2, and all of a sudden you multiply that by a negative, it's going to come down to negative 2. Or if you had one at 5 and you multiply that by negative, it's going to be at negative 5. So what's that going to do is, although you're multiplying the y's by negative, it's actually going to reflect over the x-axis because they're going up here to down here. That's going over this line. Okay, so make all the y's negative is one way to think about it, and then the actual transformation is to reflect over the x-axis. Okay, negative 3 halves. So you can make the y's negative and then multiply the y's by 3 halves, or you can do it all at once. Now this one's a little bit different in the blue here because you have 4 being multiplied by the x. Okay, remember any transformation you do horizontally or to the x values is horizontal, is actually going to do the opposite of what you think. So although this says 4 times x, it's actually going to be to divide all the x's by 4. So since it's attached to the x, you're going to transform the x. But again, since it's attached to the x, you're going to do the opposite of what you think, which we proved in class. Remember the y is isolated usually, so if you isolate the x, you actually would be multiplying by 4. But since we need to isolate the y's, it actually becomes divided by 4 when you solve. Now this negative 1 here is very similar to our adding or subtracting above, except in the red we were adding or subtracting to the x. Okay, now this negative 1 is not directly attached to the x, it's actually attached to the f of x here. So what it's saying is, like, I'm taking the y values and I'm subtracting 1. And anything done to the y's does what you think it's going to do because the y is isolated. So this is just going to, well, there's 2 ways you can think about it. It's going to go, every point is down 1. Whoa, creepy. Or you can think about it as, let me subtract 1 from all y's. Okay, so I just kind of went through the transformations here. I want you to make a table or not, whatever works for you. But go ahead and graph 2 and 3 on your own. I will come back with the final graphs. Now I suppose I should say you're transforming the original graph, not this red graph here. Okay, so go ahead and do that on your own. Pause the video. Okay, I actually did blue and green on accident, so this graph matches number 2 here. But this is negative 3 halves f of x. So the negative reflected over the x like we wanted. And then the 3 halves actually did stretch the original graph, although it is shorter than number 1. It's taller than this one. Here are the points for that if you want to double check. Okay, now this 4x minus 1, okay, this is not on the graph yet. I'll pause again and give you the answer. Okay. Here are the points for number 3. I didn't actually plot them, but notice all the x's actually shrink by a factor of 4 because it does the opposite of what you think. So they all got smaller, which means horizontally this graph will compress. And then all the y values shifted down 1 point. And you can plot those on your own to see what that looks like, but hopefully you can get a picture of that in your head. So that's how you would transform any function if you're only given the graph and not the equation. I highly recommend taking it 1 point at a time. If you have any questions, please feel free to ask. Have a great rest of your night.